So today in this video, we're going to look at sketching polynomials. So we're asked to draw a sketch of the following functions. So our first function is y equals x squared minus 8x plus 15. So our first step is to factor. And why are we factoring? We're factoring so we can find the roots of our polynomial. So let's see, how do we factor this? So we're going to have two factors because we have a quadratic, or at most two factors. The first term of each factor is going to be x, so we have linear factors. Okay, so what are the factors of 15? And we need two factors of 15 that will add up to -8. Well, 3 and 5 are going to work. So -5 and -3, when we multiply them together, we get positive 15. -3x plus -5x gives us our -8x, and of course x times x gives us x squared. So that works. So that's our factorization. So now our x-intercepts or roots are x equals 5 and x equals 3. So we're going to use these values to divide up our line, our real numbers into intervals. In particular, our intervals are x less than 3, x between 3 and 5, and x greater than 5. Our two factors are x minus 5 and x minus 3. Our function, as we know, is x squared minus 8x plus 15. Whoops. And now we're going to look at the values or the signs of the factors on these intervals. So when x is less than 3, x minus 5 is negative. When x is between 3 and 5, x minus 5 is also negative. When x is greater, when x is greater than 5, x minus 5 is positive. Now, the factor x minus 3, when x is less than or equal to 3, it's going to be negative. When x is between 3 and 5, it's going to be positive. And when x is greater than 5, it is also positive. Our function on the first interval, we go down the column, is going to be positive. This product of two negatives is a positive. On the second interval, when x is between 3 and 5, our function is going to be negative. And finally, on the last interval, when x is greater than 5, our function is also going to be positive. Okay, so we have some information here. We have our x-intercepts. We have the intervals on which the function is positive and negative. Let's find our y-intercept. That's something we forgot. So our y-intercept occurs when x equals 0, and our y-intercept is actually 15. So we have our intercepts, we have our intervals on which our function is positive and negative. Let's try and graph now. All right, so I'm just going to make things a little smaller, scroll over to the right. Let's draw in our axes. Okay. And let's put in some of our points of interest. In particular, our x and y axes. Right, so let's just label some values here. Right, so our y-intercept's actually quite a large number. It's 5. Our x-intercepts are 3 and 5. Put those in there. And now let's try and join these points. Okay. Not pretty, but it pretty much sums up what it looks like. So we're going to get some sort of parabola that looks like this. Right? It goes through the point y equals 15, and also through the points when x is 3 and 5. let's just label that y equals, what did we say it was? What was our original function? X squared minus 8x plus 15. X squared minus 8x plus 15. Good. Let's try the next one. So the next one, y equals x minus 3 times x plus 2 times x minus 1. So this is nice. Our function's already factored for us. So our x-intercepts are x equals 3, negative 2, and 1. Our y-intercept, we're just going to plug in 0 for x, and what do we get? We have y equals negative 3 times 2 times negative 1, and that equals 6. So that's our y-intercept. Let's have a look at our intervals where our function is positive and negative. So we use our x-intercepts to divide our real line into intervals, in particular when x is less than negative 2. X is between negative 2 and 1. X is between 1 and 3. And finally, x is greater than 3. Our factors are x minus 3, x plus 2, and x minus 1. Our function is a product of them all. So x minus 3 times x plus 2 times x minus 1. And let's have a look at our function on these intervals. Okay, so x minus 3 is negative when x is less than negative 2. X minus 3 is negative when x is between negative 2 and 1. Negative when x is between 1 and 3, and positive when x is greater than or equal to 3. X plus 2 is negative when x is less than negative 2. Positive when x is between negative 2 and 1. And positive for the other two intervals. X minus 1 is negative when x is less than negative 2. Negative when x is between negative 2 and 1. Positive when x is between 1 and 3, and of course positive, right? Positive when x is greater than or equal to 3. Our function is a product of these three factors. On the first interval, we go down the column. Our function is negative. On the second interval, it's positive. Third interval, it's negative. And fourth interval, it's also positive. So now we're going to take all this information and graph our function. So let's scroll over to the right where we have some space. Let's draw in our axes. Let's see. Okay. Let's put some points of interest in here. Okay, so 1, 2, 3. All right, let's label things a little bit. Okay, all right, so what do we have? So our x-intercepts are negative 2, 1, and 3. Our y-intercept is 6. On the interval, when x is less than negative 2, our function is negative. Between 2 and 1, our function is positive. So it probably looks something like this. Okay. On the interval between 1 and 3, our function is again negative. And then when x is greater than 3, our function is positive. Function is positive. Okay, that's a little bit more like that, a little smoother. Good. So this green curve is our function y equals, let's put it all in, x minus 3, x minus 2, and x plus 1. Oh, I think I mixed that up there. minus 1 and x plus 2. Good. All right. So I think we have one more graph. Okay. So our function is y equals x squared minus 1 times x squared minus 4. So we're going to start by factoring. It's not hard to factor because we have the product of two difference of squares. So x squared minus 1 can be factored as x minus 1 times x plus 1. X squared minus 4 can be factored as x minus 2 times x plus 2. Our x-intercepts are 1, -1, 2, and -2. Again, we're looking at each factor, setting them all equal to 0. Our y-intercept, we're going to let x equal 0 in our function, and we end up with y equals 4. Okay. So now we're going to consider our real line, and we're going to divide it up into intervals. Let's do that now. Okay. So let's draw it out like that. And what are our points of interest? X equals -2, -1, 1, and 2. So our intervals are when x is less than -2, x is between -2 and -1, x is between -1 and 1, x is between 1 and 2, and x is greater than 2. Okay. Our factors are x minus 1, x plus 1, x minus 2, x plus 2, and our function is x squared minus 1 times x squared minus 4. Okay, so now let's see what's going on in all these intervals. So our factor x minus 1. All right, so what's going on? It's negative, 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 positive, positive. So it's negative on every interval until we get to the interval x. X is between 1 and 2, and from then on it's positive. So x plus 1, it's negative on every interval until we get to x greater than -1, and then it becomes positive. X minus 2 is negative on each interval until we get to x greater than 2. And x plus 2 is negative on each interval until we get to x greater than -2, and then it's positive. So now we're going to go down the columns and take the product of all the factors and all the signs. So 4 negatives gives us a positive, 3 negatives, a negative, 2 negatives, a positive, 1 negative, a negative, and finally all positive is positive. So now we know which intervals our function is positive or negative. Now we're going to put all of this together. Let's do this below and draw our graph. Okay, so let's draw our axes. Let's put in some of our points of interest. Let's mark off some points on our axes. Good, and label our axes x and y. Okay. And our y-intercept is 4. Our x-intercepts are -1, -2, 1, and 2. Our function is positive when x is less than -2, negative when x is between -2 and -1, positive between -1 and 1. So let's draw that in, and intersects the y-axis at 4. Okay. So we have something that's quite symmetrical. It looks a little like this, like a W. All right, so y, this is a graph of our function y equals x squared minus 1 times x squared minus 4. Good. So that brings us to the end of our session. Where's our end slide? So if you have any questions, send us a note at info@raisemymarks.com or give us a call. Day or evening, we'll be happy to answer your questions. Thank you for watching, and we look forward to seeing you again.